I'm going to go over some p-values and power questions that will be met on your next test or exam. So first question starts with error probabilities, and you read that a statistical test of significance level alpha is equal to 0.05 has power 0.78. What are the probabilities of type 1 and type 2 errors for this test? Well, type 1 error is the alpha, so it will be 0.05, and type 2 will be 1 minus power, which will be 0.22. Second question, error probabilities. The statistical test at the alpha 0.01 level has probability 0.14 of making a type 2 error when a specific alternative is true. What is the power of the test against this alternative? Well, it's already given us the probability of type 2 error, so to calculate power, you just use 1 minus type 2 error, which will give you 0.86. The third question, power, the mean number of this situation is going to be less than 7 days. To test this claim, a significance that let's carry out with the null hypothesis is mu is equal to 7 and alternative hypothesis mu less than 7, and you learn that the power of this test is 5% significance level against the alternative mu is less than 7 is 0.64. And part A, explain in simple language what power equal to 0.64 means in this setting. Well, power, we should first know the definition for it is 1 minus type 2 error, right? 1 minus probability of type 2 error. So then to put it into a context, and also like another definition for power is that we successfully reject the false null hypotheses, the probability for that. So then how do we put that into the context? Well, we successfully reject the null hypothesis when it is false, which means that in reality, the mean days of drug patients experience after taking its new drug is actually less than 7 days, so which means the HA is going to be true. So we successfully reject this, which means if the true mean, true mean nausea time, I know my pronunciation may be incorrect, please forgive me, is actually less than 7 days, then the test has a 64% of chance of rejecting null hypotheses. So we know that our alternative hypothesis is actually true. Then what is our probability of successfully rejecting null hypotheses? Okay, part B, you could get higher power against the same alternative with the same alpha by increasing the number of measurements you take, aka increasing the sample size. Explain how this will increase the power of the test. Well, this will increasing sample size will make the standard error smaller, or in another case you can say the standard deviation will be smaller. So the sample mean varies less, right? Because it makes sense. If the standard deviation is getting smaller, then the more data will cluster near the true mean. So the sample mean will vary less. That makes it easier to detect that mu is less than 7, because in this case it's here. So the probability of rejecting null hypothesis when mu is less than 7 is true, which means that the power will go up. And that's my explanation for that. Part C, if you decide to use alpha is equal to 0.01 in place of alpha is equal to 0.05 with no other changes in the test, will the power increase or decrease? Justify your answer. Okay, so we increased the alpha, and it asks us what will happen to the power. Well, power will definitely decrease. Why? In simple language, in simple logic, you can just think that because alpha has a relatively inverse relationship with beta, which is type 2 error, so if alpha is increased, then beta must be decreased, and because beta also has an inverse relationship with power, then if beta decrease, the power will increase. I'm so sorry. So I say it backwards. So because in this case alpha is increasing, and the beta will decrease, and no, like in this case alpha is decreased, and beta will be increasing, so the power will decrease. So sorry for that misunderstanding. And so how do we put that in words? Well, because a smaller alpha means a smaller rejection region, right? Because what does alpha stands for? It stands for type 1 error. And what is type 1 error? Type 1 error is that when you reject the null hypothesis when the null hypothesis is true. So you wrongly reject it. But if you increase the alpha, you increase the rejection region. And if you decrease alpha, you decrease a rejection region. So it becomes harder to reject null hypothesis because in this case alpha decreased, so the rejection region was getting smaller, and the probability of we successfully reject, not successfully, but the probability of reject null hypothesis will decrease. So even when null hypothesis is true, which in this case it is, and more specifically when alpha is decreased, the probability of a type 1 error decreases with the same sample size and no other changes. This makes it harder to reject the null hypothesis, H0, which increases the probability of a type 2 error. Since power equals 1 minus beta, an increase in the type 2 error probability causes the power of the test to decrease. So basically, I just put all of the logic that we just did in our head into words. So you can just write it down or like put it into your own words. Part D, if your p-value for this test is p is equal to this number, explain what the p-value means in this context. So p-value, what is p-value? Well, p-value is when we're assuming null hypothesis is true, how likely, or in another way, what is the probability of the extreme value or situation will happen? So in this context, assuming that the true mean number of days patients experience nausea after taking the drug is 7 days, because that's our null hypothesis, the p-value of 0.0127 means that there's a 1.27% chance of obtaining a sample mean number of nausea days as small as or smaller than, because in here, I mean, it does not specifically say small as, but we sometimes we just don't care about the bounds really. So you can also say smaller than, that's okay. With the one we observed in the direction of fewer than 7 days, which is not our alternative hypothesis, just due to random sampling variation. And yeah, if this question gives you more details, like the sample size, what is really that number, then we can say when n is equal to blah blah blah. But because in this case it does not give us anything, so that's the best ability we can reach to interpret that. Okay, moving on to question 4. Is Austin aware? For his statistical project, Luke is performing a hypothesis test to compare the mean number of tattoos per adult in Austin to the mean number of tattoos per adult in the rest of the United States. The true mean number of tattoos per U.S. adult is believed to be this number, according to a recent Harris poll. Based on a survey that Luke conducts in downtown Austin, he calculates a z-statistic of positive 1.40. Part A. Since Luke believes Austin to be weird and thinks that the mean number of tattoos per adult in Austin will be greater than that for the rest of the country, his alternative hypothesis is HA, where mu is greater than 0.21. And based on the z-score that he calculated and his alternative hypothesis, calculate the p-value for Luke's hypothesis test. Okay, so how are we going to do that? It seems like gives us a lot of information. So first, let's just to recollect all of the information again, like assort them a little bit. We know that the mu, our null hypothesis, will be equal to 0.21, and our alternative hypothesis will be mu greater than 0.21. And it says that calculate the p-value for its hypothesis test. P-value is basically that because we don't know the standard deviation, right? We don't know the sample mean. So we don't know the sample mean, we don't know the standard deviation, we don't know, basically this seems like lacking a lot of information, but actually we can achieve that in another way, just using the z-score. So z-score by default, it has a mean of 0 and standard deviation of 1. So because we want to know that if the probability of mu is greater than 0.21, we can say that its corresponding z statistic 1.4, which is corresponding to this value, z greater than or equal to this value. So if you want to type into your calculator, it will be, or you can write it down in your paper first, p parentheses z greater than or equal to 1.4, and it will give us 0.0808. So that's the answer for part A. Part B, explain in context what Luke's p-value means. Well, it means if the true mean tattoos per adult in Austin were really 0.21, then the probability of getting a sample mean at least this high, which is z greater than or equal to 1.4, we just did, is about 0.080, which is 8.08%. Part C, Luke's lab partner, Clara, thinks that Austin adults will have a lower mean number of tattoos than adults in the rest of the United States, so she gets her alternative hypothesis as this. Based on the same z-score of 1.4, since she used the same data as Luke, calculate the p-value for Clara's hypothesis test. Because Clara says it will be less than this, so we can just grab the same z-score and put it into the left region of it, which will be 0.9192. If you do the same thing on your calculator, then you will get that number. Part D, Marie is a friend of Luke and Clara, and while she is not even taking statistics, decides to join in on the fun. Mary decides to use the same data to perform a two-tailed test. So her alternative hypothesis is alternative hypothesis mu is not equal to 0.21. Using the same z-scores as Luke and Clara, calculate the p-value for Mary's hypothesis test. So basically, we already did for part A, Luke's probability, which will be 0.0808. We just use that number times 2, and we will get the probability of Mary's hypothesis, which will be 0.1616. And if you want to graph that, just make a normal curve and then shade both the left and right region, and same for these A and C. For A, you only shade the right region, and for C, you only shade the left region, which will be a lot bigger than part A. Okay, so that's it for this. I hope it will win quick, but I'm not sure the time for this. How long is this video actually take me? But that's basically an overview for p-value and powers. So I hope you learned something from this video.